This is a typical scenario as a message lifecycle on the SQS service. So as you can see, the step one is that you have a sender who's sending the message. So when in the queue, whenever you send a message to the queue, what happens is that again, because of the scalability and horizontal scalability of Amazon, what they do, they distribute that message to multiple servers, right? The SQS service that they have. In this particular case, I've, for example, if it is being duplicated to 2 different servers, so the message is being stored in these 2 queues. That's the very first step. Now, the visibility timeout clock starts right away, meaning the message will be visible until that time runs out, right? Then what happens is step 2 is you have your receiver, right? Which is basically whose job is to retrieve the message. So this receiver is basically reading the queue. Of course, it's not reading to all services, and you will see in a few minutes when I show you the code as well. This receiver is actually talking to the queue, right? And behind the queue, there are many servers which are basically tied with the same queue. Whenever you're making a call, say, hey, is there a message within the visibility timeout clock? Yes, there is a message, and it can probably return the message to the receiver for processing. In my 2 scenarios that I gave you, one was the image and the other one was the file upload with the registration of the user. So these are 2 specific user scenarios. So the file that has been dropped, for example, for registration is sitting here on one of the queuing servers. That gets sent to the receiver, and that message gets received. And then it's the job of this retriever or receivers is to actually go ahead and start processing that file. So that's step number 2. Once that file has been retrieved, then you can go ahead and delete that message. So this way it would actually avoid the duplicates of the same message being read. So you want to make sure that you delete the message. And if you have multiple receivers, then they're not really actually reading the same message again and processing it again. So this is a typical SQS message lifecycle. Again, it becomes very powerful, first of all, because the Amazon architecture is as such that they have a distribution of servers across the board, and then you don't really have to worry about the scalability. The second thing is the guaranteed of it to be delivered, because the message is dropped in multiple servers, so it is guaranteed that somebody's going to pick it up, provided your receiver and the consumer is rock solid. And you can also make sure that this is all done through the offline mode and not really getting those client server tied up during these hefty calls.